Hello and welcome to this video. Let's talk about what purpose is being solved while manufacturing a mold for a molder. So, without wasting any time, let's get started. So, as you can see, there are different reasons which are underlined or understood when it comes to manufacturing a mold, right? So, it can either be a mold for a short run, right? For example, for 3 to 4 months. It can be just for the testing purpose that we are testing a particular product to see how it will behave when it comes to its performance and if the market will accept it. And then we may also use a mold for experimental purpose just to know how the molten material will behave before it gets cooled down, right? Or to test the behavior of plastic. And then we also need molds for a new product which is just supposed to be launched, right? Or has been launched but has to be commercialized in the market. So, and the last reason is that it can also be used to increase the production of an existing part. For example, if the mold cycle is such that the productivity is not at par with the requirement or the demand, we may use another mold or duplicate mold to ensure that the productivity increases. So, whatever the reasons is, right? Whatever the reason is, the decision has to be made while being very wise because molds are not cheap, right? Molds are not cheap, period. Conversation ends here, right? So molds are they are associated with some cost, and we must acknowledge that, right? And the designer is someone who will take that decision. What kind of mold will suit the requirement of the molder, and how the things will go from there. Okay, so let's talk about the prototype mold. So look, prototype mold is basically used to make samples of a new product, right? And we are making a new product, we are sampling a new product. Why? Because we want to understand its shape, evaluate its shape, right? How it looks, how it feels to the eye or touch, how well it will work, and if it will meet the durability and strength requirements, right? And as a matter of fact, the same molding or same product is subjected to expected stress and wear, right? So that expected stress and wear is something which shows the similar results, or the results are same when we compare to a handmade product or machine product, right? Or assembled product, right? So, and again, when it comes to the performance, or even the results are more accurate or rather cheaper than a computer simulation, right? So we need to understand that. So when we are manufacturing a prototype mold, the most important objective is that the intent, the design intent has to be captured. The whatever expectations we have for the product, we need to meet, but at the same time, we don't question the productivity of the mold because the intent or the ultimate goal is just to understand how the product will look and how it will kind of behave when it comes to performance. So there can be different ways through which we can decrease the cost of the mold. For example, the ejector system can be quite simple, just making use of air directed towards the edge of the product for it to eject manually. No use of advanced ejector system, or we can simply make use of ejector pins for manually pushing them so that the product can be ejected. Secondly, the since the productivity is not quotient here, so the cooling is something which is not time limited. So there is no such requirement of adding cooling channels, which will further reduce the cost of the mold, right? And thirdly, the material can be either mild steel or aluminum, right? So long they are meeting the expectations, or so long they are strong enough against the heat and pressure of the molten plastic, they are be able to bear that, right? And then the for example, if there are threaded components, internal or external threads, the threads can then be, instead of kind of cutting out or adding a permanent insert, we can use a loosened insert. Then that can be ejected, and manually it can be unscrewed by hand, right? And then the side walls of the product can just be used, or can just be made using loosened inserts rather than your side cores. And whatever holes are there or pockets are there in the product, that can be machined after the product is ejected, and after it's sufficiently cooled down, right? So all these factors are very important when we talk about prototype mold, but we are just trying to minimize the cost. And again, if you can see in this figure, the left one shows you a prototype mold for a lid, which can produce a lid, 4 lids at a time, 4 cavity and 8-inch diameter. And then on the right, you can see a container mold, right? Here, the stack, the mold shoe, and other plates, excluding the cavity and the core, are borrowed from a production mold, right? Now, if there are different prototype molds which we need to make, instead of making stack for each of them, making plates for each of them, we can rather make a single mold shoe to accommodate different sizes of core and cavity inserts, right? So this is something which can be done to reduce the cost of the prototype mold. Next, the runner system can be just a screw gate directing the flow into the cavity, or it can be a simple runner and an edge gate. And then when the product is ejected, that gate can be cut manually. Let's now talk about experimental molds. So experimental molds, basically, they are used to study the behavior of the plastic, the injected plastic, right? So it has gotten more to do with the chemistry here, right? So now if there is a newly developed product, we need to understand for that the molten plastic, how it behaves, right? For example, if we have to make sure that the cooling is something which is causing an issue, right? Or the cooling is excessive, or cooling is not adequate, or the mold is not getting cooled evenly, right? So that relationship, that analysis can be done in an experimental mold, right? So the difference is that the basic usage is to establish the behavior of the plastic in a newly developed product during injection, so that the cycle time can be optimized, and the mold can be tested for any type of defect during packing and filling, and also ensure that the plastic part is ejected at the same cycle time repetitively, right? And for that we need some kind of ejection system rather than being done by an operator which is variable, which won't give repetitive results, right? And obviously we can still reduce the cost by making common mold shoes or using the stack which is interchangeable, right? But again, we can compare it to a simple single cavity production mold, right? For it to be able to test it or experiment it, right? Because if the cooling is excessive, the cost was which was being incurred before can be cut down by reducing the cooling channels. The if the cooling is something which is not adequate or which is not evenly spread, so during the experimentation we can get to know that, and we can work on the cooling channels, right? Similarly, on the injection, because the cycle is repetitive, so we have to make sure that the cycle time is same for each cycle, right? And for that, experimental molds come handy. So if you can see here, it's a four cavity experimental mold, right? Again, the behavior is something which will be emulated, right? The production mold, whatever the number of cavities are, no matter how many cavities are there, the experimental mold would emulate or replicate how the production mold will behave. Although the experimental mold won't contain that many cavities, but it would surely help in giving us the valuable insights of what should be the optimum value of injection pressure, melt temperature, mold temperature, injection speed, and other things which decide the quality of the product when it comes to defects, as well as it decides the cycle time, because the cycle time during the start of production and at the time when the production is repetitive and is more or less autonomous without involving any interjection of you know or in simple words, if the product is getting produced repetitively with the best possible quality, to reach that level, an optimum cycle time needs to be set, and that can only be done while experimenting through an experimental mode. When we check that this is the best combination of parameters like injection speed, injection pressure, clamping force, your uh, melt temperature, mold temperature, what should be the packing time, what should be the filling time, right? When all these parameters are fine tuned or tweaked for the optimum results, then it's a time for the production mold to be manufactured. Before that, all these things can be done on an experimental mold, right? Okay, let's now talk about the combination of prototype and experimental mold. So, for example, if a molder wants the product to be tested on the field and he wants to make few hundreds or thousands of samples just to send the samples to the customer, right? For them to analyze visually as well as how it will behave in the field. In that a case, the combination of experimental and prototype mold comes handy, right? Again, it's an inexpensive mold, although it should be fully automatic, but there is no need to make it 100% efficient. We can somehow compromise on the efficiency by using suboptimal cooling channels, or probably we might still not use a mold as expensive as a hot runner mold, right? And again, just to establish how the product will look, and at the same time how well it will be accepted in the market, by just manufacturing some samples. And it's again, there is no need for uh, giving any finishes like engraving, right? And at the same time, I can also test that experimental mold or the combination mold with or the combination mold for shrinkage, because shrinkage is something which gives variable results with time, right? So if a few hundred samples are manufactured, out of that sample lot, say 30 lot of samples, capability study can be done, and CK, CP, CPK can be found and check to know if the process is capable and repetitive, right? Dimensional inspections can be done, layout reports, and then we can get to know that if how the product is behaving, or what are the dimensions, are they getting repeated or are they consistent throughout the you know uh, throughout the set sample of products, right? are they within specification, or are they varying a lot, or are they coming out of tolerance, right? Because shrinkage is something which can change the dimensions or tolerances, which is why very, very tight tolerances are not much possible in plastics, but still, uh, there has to be efforts made towards this direction to at least contain the dimensions within the tolerances, even if they are somehow on a looser side. So for that, we use a combination mold, which also helps us in establishing how a product would look like or appeal to the eye or touch, or how well it will work, and if it meets the strength and durability requirements, as well as we are able to see if it's going to be accepted in the market, rather than directly leaping to the full-fledged production mold, which might be a reason for incurring losses. Given the fact, if it's not accepted in the market, what are we going to do? We would have to cease the production, right? So why why not manufacture a mold which is, again, which delivers suboptimally, but at the same time we can get a few hundred or thousand samples out of it to check its market acceptance, as well as to establish the shape, right? There can be field testing, which can tell us how well it will be behaving. There can be inspections to tell us how well it will be contained within tolerances, and how well it will, you know, uh, behave when it comes to shrinkage. Let's now talk about the production mold. So any mold other than experimental or prototype mold is your production mold, right? So production mold is something which will give us the pieces or the products which can be directly sold to the customer. So before we decide what type of mold we need, will it be a cold runner mold? Will it be a hot runner mold? What kind of gate it will have? How many cavities it will have? That will all be decided based on the set of information. First is the number of pieces to be molded. How many pieces are to be molded? Is it to be served for a period of 5 years, say, or it's just a requirement of 3 to 4 months, wherein the production will be 24/7? Will the set quantity required be delivered in a number of years? For example, if we need 10 lakh pieces for 5 years, that would mean 2 lakh pieces every year. So we have to decide the mold basis on that. Next, what kind of material, whether it will be P20 or S13, that will be dependent on the fact as to how long the mold will be in service, and what are the conditions the mold will operate in, say the what type of machine the mold will be mounted to, right? The throughput of the machine is very important, because now we have the information on the cycle time, because we have already experimented it. We have the information on the packing time, filling time, the injection pressure, the melt temperature, the mold temperature, the cooling channels. Optimum cooling channels have been set up now, right? And all these informations, once known, will help us in exploring different set of possibilities, right? And then choosing the best out of that, which will be most economical as well as productive. Let's now talk about new products. So if, for example, the purpose of the mold is to make a new product, right? And that product, although has been tried and tested, but we still don't know if the public or the customer or the market would accept it. It can be a hit, it can be a flop. So basically, if we are making a totally new product, a new invention, or modifying a product, an existing product, into a product with some modifications, better design, and or a product with a different material, right? So there are three considerations, three possibilities. First is that if the market will accept it in its new shape, right? Second is that whatever modifications were made initially, are they sufficient enough, or will it still require more modifications, right? Or if it's a new product and there are complaints or suggestions from the field, what will be the modifications required? Because that will determine the cost of the mold, right? Because a production mold can be a single cavity mold or a multi cavity mold. It should have better cooling channel, less cooling time. It should have advanced ejector mechanism. It should be automatic. More automation should be there, right? And the cavity should be such that the production efficiency is high, right? That is something which will reduce the cost of the product. But what if the product fails? The loss is going to be substantial. So, which is why the third point says it can either be a disappointment, right? And then the product will soon disappear. So it's up to the OEM to take all the risks, right? And at the same time, I'll tell you a workaround on it. So if we were to reduce the loss, right, we can make several smaller molds to be run on smaller machines, because the first mold can be made at a less price because it is smaller one, has less cavities, has does not have all the advanced features, right? So that mold can help us decide if there is a need for making several other smaller molds similar to that to meet the demand, because if in case the product is highly successful and there are different criteria for the product to be successful, or there is a different timeline for the product to be successful. If there is a monopoly, the product can be successful and product can be a hit, huge hit. But if the competition suddenly appears, the sales can certainly decrease, right? And again, if the product is such that the demand is not perennial, if it's a seasonal demand, say during the month of March, April, the demand for tomatoes in India increase. In that case, the demand for the crates increase, and crates are molded products. So the vegetable crates are more in demand during that season. But that doesn't mean that they will be in demand throughout the year. So planning has to be done according to that. If a mold has to be manufactured with the most optimum costing, right? It should 100% ensure that the whatsoever product is coming out of that mold will be accepted and will be sold in good quantities. So a mold with advanced features, right? A hot runner mold will valve gates, and then your you know degating, automatic degating, trimming of gate, and then advanced ejector mechanisms, right? All these things will increase the cost of the mold, and of course the high number of cavities also. But the cost of the product will be less, because for that to happen, we must produce the product in very large quantities from that mold. And on the other hand, if we are not much risk averse and we try to take calculative risk and ensure that the collateral damage is as less as possible, we ensure that the mold is not made with all the advanced features, not high number of cavities, but a limited number of cavities, a smaller mold, make products out of it, test their acceptance in the market, and if at all we get to know that we need more such products because the product has become very successful in the market, then we make more such smaller molds, because it is easier to find a smaller machine than a larger machine, and those molds can then meet the further demands of that product. But again, the cost will not be that less. The cost of the product will be higher on higher side as compared to when a high production mold with high cavitation is used, right? Because that mold is capable of making much larger number of parts as compared to a smaller mold in the same amount of time. So that will certainly mean that the cost of the product coming out of it will be lesser as compared to the cost of the product coming out of a mold or a smaller mold, which is not that efficient in terms of the number of parts it can produce in a set time. So the important takeaway here is that all these questions, they don't have very clear answers, right? But at the end of the day, we need to decide on something. So if you see, for some products which are seasonal and the demand is something which diminishes over a small period of time, or it has an earlier saturation point, such products have high demands until some competition appears, as I just told you, or a better product, of course, comes along. Now, in that case, the demand can soon disappear, right? So, in such cases, a better approach will be to build a mold which is capable of meeting that demand plus minus 25%, right? There is some kind of tolerance that if in case the demand surges for, so it can at least meet that 25% of the surge. And if at all the stoppage is unanticipated and the product fails, then also the loss is not that substantial, right? So a very careful decision has to be made. Different choices exist, but the best possible choice is something which is at the discretion of the molder or the customer. Let's now talk about the existing products which are required in very high quantities. And such products are, by the way, timeless. That means that the demand may be more or less throughout the year, depending upon the seasons and depending on the economy as a journal, right? But the annual quantities are more or less constant. Their demands, that doesn't change. And again, one solid example is your stadium cup, and then we also have examples like food containers, packaging containers, for packaging. And then we have some medical devices, right? Like vials, petri dishes, slides. So their demands, for example, during the COVID season, the demand peaked for some medical devices, right? That can depend on the circumstances, but that doesn't mean that they will never be used, right? So the demand can surge or the demand can correct, but at the same time, it has to be there throughout the year. So for those products, we usually prefer a mold which is high cavitation and has all the advanced features. And the cost of that mold will definitely be high, but over time, the cost can be, recovered because very high quantities of parts will come out of that mold. And as a matter of fact, we not only consider the cost of the mold here, we also take into consideration the injection molding machine, the post mold operations, the automation, the packaging, the assembly of that product, because the cost is something which will be calculated out of the totality. But at the end of the day, what is important is that if that product is being sold in high amount, the cost of that product or per product costing will be quite less. Doesn't matter if the cost of the mold is high, that will be recoverable over time, right? So the demand does not change for those products. I told you what kind of products are those. And again, if you can see, this is a high volume production mold for a stadium cup. See the cavitation here, see the stack mold. Not only does it have two core cavity interfaces, it has how many cavities? 12 cavities, and it is able to produce a high quantity, 12 cavities on one side, so total 24 cavities and high amount of good amount of production in a set period of time. So again, such products should viably be manufactured on a an advanced mold, and again the cost of the mold can be recovered with time because the cost of the product will be less and the quantity will be very high. So all in all, multiplying with the quantity, multiplying the cost with the quantity would certainly offset the cost of the mold. Let's now talk about products which have limited demand, but they are still required in large quantities. So for example, as I just told you the example of crate, during the peak season of tomatoes, the crate molds are required. Crates are required for which molds will be manufactured. For example, if there is an advertising campaign or if there is a festival like Diwali, which we celebrate in India, before that festival, we know that we will have to gift these many quantities to our employees. So the order are placed beforehand in advance. So in that case, we know how many products we need to produce. And then again, there can be cases wherein there can be a special occasion, right? There can be special uh, uh, festivity occasions, right? So again, uh, quantities can be known as well as unknown, right? But at the same time, the demand is something which does not stay throughout the year. So what kind of molds are recommended? We would still recommend a high cavitation mold, which will be able to produce a high amount of parts, right? But again, for that, the cost of the product will be less, and the machine also would be required, which is larger enough. So again, the decision rests on the employer or the customer. But again, there can be a workaround. There can be an alternative, which is the uh, use of a smaller mold, which is which has a less number of cavities, and then they would outsource it from multiple mold makers, beg your pardon. And again, but the downside of this is that the cost of the product will be high because one, they have to outsource it, so the cost from different vendors will be different. And of course, if we get multiple molds made from a single vendor as against those molds being made from different vendors, the cost will be higher when those molds are made from different vendors because every vendor would quote a different cost and there would be no discount, right? Because the vendors are different. So again, the cost will be on a higher side, right? And then the more number of smaller machines will be required, which means larger investment, larger space. Again, the cost will be on a higher side. So for the products which need limited quantities, which need quantities for a short amount of time, not throughout the year or throughout the life cycle of the product. In those cases, it's the choice of the molder if he wants to pursue making a mold which is costly, but the cost will be recoverable given the fact that the cost of the product will be less. And the second scenario is that if he gets the part manufactured on a mold which is a smaller one and the quantity of those molds are multiple, so much so that if there is a surge in demand, the demand can be fulfilled. Let's now talk about molds for short runs and small production. So for short runs or very limited productions, right? And as well as when the products are simple as well as on a smaller side, right? And we know that the annual quantities are also small. So there are two alternatives here. So either we choose a mold with the least amount of high productivity features, such as hot runners or your good cooling, or we use a universal mold shoe and make cavity and core inserts for those products and insert them in the universal mold shoe. And we can buy those mold shoes from standard mold based manufacturers like DME, Hasco, Fatuba, so on and so forth. And those mold shoes are universal, meaning that they can be used for running a single insert, for inserts in pairs, for multiple inserts, or even for the inserts with different products, for different products. And these molds are changeable. And for future, if we were to change the product or replace the insert with the another insert of a different product, we can do that. And these mold bases are easily available all over the globe. DME has its global presence in Europe as well as United States as well as in Asia, and different standard mold bases are available which can be used. And again, since these are universal mold shoes, the cumulative cost will be less over time because we know that the quantity is less and the time period for which the production is going to take place will also be very less or limited. And the uh, products are also not that complicated, so much so that any customization is not required. So standard mold bases are readily available, and we also have this special mention to use standard mold bases because, and as a matter of fact, mold base and mold shoes are one and the same thing. So if why it's mentioning to use uh, standard mold shoes or bases is because those are accepted globally for different inserts, right? And that would certainly help the molder save cost on buying different mold shoes or mold bases for different products because each product is simple, doesn't have many undercuts or any undercut for that matter. So, for example, let's assume a plastic spoon, right, and a plastic container. So we can mold both the products on a single mold using a universal mold shoe and mounting cavity and core inserts on them and uh, running them on the machines. And again, if we were to change the replace the plastic container with say a plastic plate, right? So we can change the insert keeping the mold shoe same. So that will be very cost efficient or cost effective. So yes, these were the insights for the different types of molds which are required when it comes to meeting the demands of the market. And it totally depends on what type of product we are molding, how many such products are required, how much costing those would need when it comes to keeping the customers intact because a very expensive product would still not be accepted in the market, right? So different types of molds are tailor made for different types of requirements, and this is very important to understand because there is a good amount of cost associated with the mold. And in order to ensure that the losses are as less as possible, the production is such that not only does it meet the demand but also pays a good amount of profit and payback for the customer. So we started from a prototype mold. Before that, we started what exactly is the purpose of making the mold. We need to understand that, right? Because many things come into picture here. Not only does the mold have to be with a set number of cavities, the material also is important, whether it's going to be mild steel, aluminum, or P20 or S13 or whatever kind of tool steel. Then we studied about experimental mold, beg your pardon, prototype mold, then experimental mold. Then there was this combination of both experimental and prototype mold. Then we talked about production mold, the quintessential production mold, and then we talked about new products, existing products, high quantity of products required. Then we also talked about limited quantities, limited product, and then again products for short runs and very limited production. So this was the whole lecture which was kind of planned around the requirement of the mold, depending upon the requirement, or depending upon the type of product required. So I really appreciate you guys taking time out and joining and watching this video lecture. Thank you for watching this video. I'll see you in the other video.